Welcome to another unit in this SPSS course. This time I'm going to talk about how we can use the R essentials for SPSS to conduct a Tobin regression. So first off, what do we understand by R essentials? The R essentials are like a plug-in or add-on for SPSS, which allows us to use additional functionalities in SPSS, so additional commands. And well, if you never heard about them, just feel free to visit the corresponding unit in this course, where I explain in detail, first of all, what they are and how you can get the relevant data files, how you can install this, and how you can select specific commands or activate specific commands. Well, at the following, I will just assume that you already installed all the necessary files and already activated the corresponding functions. So getting back to my original comment, I'm going to talk about how we can conduct a Tobin regression. So what is a Tobin regression? Well, in some cases you also find this under the term of censored regression or regression with censored data. Meaning we cut off some part of our variable. So instead of the linear regression, where we basically assume that our dependent variable can assume all values from minus to plus infinity, here we assume that is limited to an upper and a lower bound. This will then also impact as well our coefficients as our standard errors. And well, if we want to do this, we can simply go to Analyze, Regression, and here in the upper part we find Tobin regression. If I click on this looks familiar to what we know from normal regression analysis. So we have dependent variable, so for example the weight, and we have a list of independent variables, so for example the height. The different, that's actually the part in between. That's what's different. Here we have an upper and a lower bound. So which of these values do we actually observe? And for this we need to keep in mind, and you might find this out when you generate a frequency table or histogram for the weight variable. The weight variable only takes values between 40 and 115. So if I introduce here a lower bound of 38 and an upper bound of 120, it's basically containing all values, so it's the same as the normal linear regression. This is what I want to show you first. But before we get there, first off, here you have to select what is the approximate distribution you assume for your variable. Usually, if you go with regression, you usually work with a Gaussian, or in other words, with a normal distribution. So we usually leave this as is, and then can just click OK. And here we get our results. Just to show you that those results are not really biased, I will just conduct a normal linear regression. Here I go to linear regression. Again, dependent is weight, independent is height. Conduct this regression. And here I see I have a constant of minus 97.866 and a height of 0.943. If I turn back to my results from the Tobin regression, minus 79.866, and here a slope for the height of 0.943. So this is actually exactly the same, because we did not cut off any of the values. The lower bound is smaller than the smallest value. The upper bound is larger than the largest value. If, however, I now cut off some values, so in other words, as I said, the minimum is 40, the maximum 115. So if I just go here and say, well, consider only those values, those people with a weight 42 upwards, so I'm actually excluding the guy with 40, and only those guys up to 100 kilograms. So I cut off everyone with a weight above 100. Then now click OK, and we see those values actually deviate from the uncensored ones. Here, the intercept and the slope are different than in the example before. Not significantly different, because we also did not exclude so many values, but they are different. Similarly, our standard errors are different, and correspondingly the t-values, or here the z-values, and the corresponding significance level. And well, that's then basically the idea behind a Tobin regression. If I set an upper and a lower bound on my dependent variable, I might get different regression results as if I actually assume them to be continuous. And thereby, whenever I have an upper or a lower bound for my variables, I should run a Tobin instead of a normal unrestricted linear regression. Well, that already covers what I wanted to talk about in this unit. So I hope you enjoyed it. And if you want to see additional input on SPSS, feel free to visit the rest of this course or have a look at the corresponding playlist. I say goodbye and see you next time.